Okay. Let's try to do this too. Oh, it's on. I thought this gave me way more control. Okay. Just turn this low. Oh, wait. Okay. So what we're looking at here is a new design. Basically, I bought... wait, we can't do this. Honestly, this is gonna be a short stream. I feel like whenever I'm off the... Bro, like... Whatever, man. What is going on? I thought I had this saved. Damn, I don't know, This stuff gets me so... Especially with the music, man. Why is this music so sad, man? This shit just gets me so fucking bummed out. First up, we gotta do this. Alright. So, I got these bearings, and we can just start over, right? This is pretty much the bearing. And the thing about this is it's pretty tight to move. It's kind of difficult to move it around, actually. So what I want to do is maybe just have like a let's just do it in the other thing, because then I have so many I have so many easy... Oh, actually, I wonder if I could get a CAD for it. Whatever, it's fine. So, actually, I wonder if I can export my variable studio. If I could export my variable studio, I'd prefer that. Copy table. We'd still need to import some assets like the stepper itself. But that shouldn't be too hard. Roll this forward to our variable studio, and let's just paste this. That's what I'm saying, bro. Why is there no... Oh, wait. Oh, hell yeah. Why isn't it... Why isn't it, So we have this... Oh, but we can't modify it? That's not so bad. Right, yeah, so we need to just make this big blue. Okay, so now we shouldn't have any overlap. These are the 608s. I don't think you can prefix them with numbers. That's why I had to name it like this. But it's fine. So for now, all we want to do is test out whether or not we can even move the bearing with... Well, I mean... I kind of want to do an intermediate goal here and just try to, And the other thing about this is that we can make this freaking hollow. So when I do this, why don't we just move this in? Okay, wait, let's just start over. Okay, so this is just going to be called the bearing test. Okay, so all we have... Should we do 2 bearings? We should probably test both of them. But I don't know, maybe I should test one of them. Okay, so what I was thinking is... You draw a sketch here. This outer thing is going to be like... oops. Big bearing OD. And then we want like a... Oops. Or actually... this needs to be... Well, actually, it's the distance from here to here. And this probably needs to be a stepper width, right? Something's wrong. Oh, it's because of this. What's wrong here? Oh. Yeah, we can make this stepper width. And then plus 2 times wall. This also needs to be plus a wall. Okay. And this line... Oh my god. So then we have... Wait, but this... No, yeah, we messed this up. We're gonna have to... delete this. Oh yeah, I was playing around with fasteners. Fasteners are a little goofy. Someone earlier asked me what I miss about. I feel like the fasteners interface is actually a little bit. Honestly, no, but they both kind of stink. But we can just delete all this. I'm trying to figure out if I should do it like this, where I have one here and then I copied it and I put it up. I put it in there. Okay. Yeah, it doesn't have to fit the whole thing, right? Oh, but this... Wait. Okay, what are we trying to do here? So first off... Let's... Oh, what? How does that work? Okay. So the bearing just goes in there. That's it. We just push it in there. So then let's put the bearing in. This is where it gets kind of awkward, right? Because alright, well, let's just make a just a plain bearing, just for whatever. And that's the whole part. I mean, that's effectively the whole part. So then in assembly 2, and that's literally correct, but we do need to mate it still. Oh, what the hell? But is it gonna update? Right. Can we just undo? What the hell? Okay. We want to fix... Wait, what? Okay, so now in the interior of here, it needs to be clearanced. I mean, I think you do want a tight press fit. I think I made it like 0.2 smaller than the OD in the last design, but I feel like maybe I don't need that with these big ass bearings. I don't even know how I'm gonna clamp it in. I'll probably use 2 vices antipodal. Okay, let's just get this thing so we can freaking print it, man. So now we need a new part. And we can put it in here. We're gonna sketch on the top, sketch normal. See, this thing is going to be it's gonna be bearing ID minus 0.4. If we do that, we can make it even looser. About 0.8. 2.6. Okay. Now this thing, we can also just make this like this. I mean, we don't really need... The one thing that we are going to need to do, and we can make this... Okay, so we need to figure out... Okay, wait, so we need to import... Oh, import just immediately... Is there a way to, import from another document? No, that doesn't seem like what I want. Yeah, because I want to... Oh, wait, actually, you know what I can do? Oh, shit, wait, hold on. Just store this. Okay, in the assembly file, I can insert other documents owned by me, pen tilt stepper. Oh, is it an assembly? Yeah, it's an assembly. That thing looks big, man. What the hell? What the hell, bro? Okay, so let's just do this. Now, how do we want to do this? Because we want to mate that with that. I'm going to flip it. See how it's intersecting a little bit? So when we go back, we're going to have to go back to this thing. Is it this sketch? You're going to make this. So maybe just make it 2 times wall. Just 5 more. How's that? See, that seems pretty good. The only issue here... Oh, well, first off, this is so stupid because how are we going to mount this thing? I mean, we could just put walls around it, but this is so crazy. Okay, the design originally was that we're going to have... Let's make another assembly. And then let's insert other documents, assemblies, step. Okay. The idea was to put... Is there a way to rotate this thing? There's gotta be a way to rotate this thing. Oh, these are rotational things. Yeah, so you just gotta go like this. Okay. So the idea was to put this... I guess sort of like that. And then the worm drive just sits on there. I guess we want it further over here. And then we want to rotate this like this. Kind of like that. See how much it's interfering though? That's sort of my bigger worry, is like just getting the geometry right here is gonna be a pain in the butt. I mean, I feel like this is a better design than what janky test thing we have going on right now. I wonder if I can just do a Okay. Well, actually, I want to reprint that thing. Can we go back to... Is it in here? I think it is in here. So this is bugged out. Wait, why is this sketch not... Oh yeah, that's just a nothing burger. Let's try to print this again. I know that it's just gonna... I feel like it's just gonna fail. And I have to go to class anyways, so... But I really do want a nice worm drive I can have work. Controlled by the stepper, so... Let's just do that. No, I need to charge my phone. Okay. Oh, and then I got a another motor that we can try. Hopefully, maybe that might be something to try out. There's no reason why this should succeed. I feel like, but whatever. Okay, because the problem is these walls, so this to here. Oh, what? 12? Oh, that's yeah, that's not right. What we want is this center dist, min dist. Okay, that doesn't make any sense for me at all. We just want to know the distance of these walls. So let's go to this. Probably this. Alright, yeah, what is the distance between here and here? Oh, it is something weird. I wonder if we could make it wall. Is that stupid? Now there's a big gap in there. I mean, the real issue is... What's up, Ole? What's going on, man? So we need to get a, what if we just use the one that we already have? What is it called? Worm drive. It's too long, but maybe we could just pull it back. Okay, let's just do the mate here like this. We want it to be on this, and then we want the offset to be 22 in Z. Yeah, as long as it doesn't cross that top view. Probably already sleeping. Yeah, me too, man. I'm tired. Oh, what happened here? Actually, this looks pretty good. All we need is a little bracket here. The main problem is that with all these angles, it's hard to get those perfect. So wait, we want to rotate this. It's very hard to tell. But I feel like it would be something like that. So let's just click. Why isn't it accepting my commands? So I'm trying to think about the assembly. Oh, and I want to do one more thing. When we do this. Yeah, there's absolutely no reason for this. Oh wait, was that in this sketch? Okay, yeah, that's way better. The only problem is we need to figure out how to do this. Oh wait, we want the Okay, so that's not exactly right because we actually do want this one to go to the middle. What the heck? Ugh. Does that seem right? This thing is using projected geometry. Wait, why did I even do this? What the hell is going on with me? Alright. So now we have a plate. I don't know why this needs to be so thick. Because, dude, a 10 mil plate at that big is going to take forever to print. It's just such a waste. So we'll have to fix that. But right now I'm more curious about... Oh, that's 90? What about this? 80. Does that check out? I feel like that only kind of makes sense. Let me plug in my phone. Let's check on the print. I feel like this thing is gonna be totally busted, man. I don't know. It only starts happening towards like the... Look at that stringing though. You know, it's interesting. You never see people mill PLA or anything like that. I don't want to look up a video of that. Yeah, I'm curious.
Hey guys, and welcome to Functional Print Friday. So last week I showed you guys this scale calibration weight set case. So inside here, if you missed that last week's video, is a calibration weight set for scales that I designed. And very happy with this with the exception of the lid. I've never been happy with how the lid came out of this guy, mainly the lettering on it. Very happy with the texture on here, but partly because of that texture and partly because it's just hard to print lettering on the underside of something. The face that goes down to the bed, you can see it really doesn't look very good. I asked you guys for some help on how I could do this better, and you guys schooled me. So let's go take a look at the comments from last week's video. All right, let's see what you guys wrote. So start from the bottom. From DB, I print text on surfaces just like that without issues. Use glue stick or something similar to an adhesion. I also squished the material into the textured bed more than a smooth bed. Yep, definitely good thoughts. I didn't use a glue stick in the original print. I do think I had the Z height as low as I could get it to get the maximum amount of squish into the textured bed, but I haven't tried a glue stick. I might have to give that a shot. Next up, parts Dave, you could print a vinyl adhesive label over it. Also a great idea. And actually I have a dye sublimation printer that will do labels. They're small. It'll only go to like a business card size, but realistically that's all we would need. We could have like a recess in the top of the lid to match the size of the label, so it's just below the surface. And then go ahead and just put the label after we cleared out the supports that would inevitably have to be there. The only downside I can think of is the vinyl labels, or really any label, is going to be pretty thin, and you're probably going to see the texture of the supports underneath unless there was a way to clear that up. He also goes on to say that we could do printing the letters separately in another color and then press them into the recesses. Also a good idea. Fairly labor intensive, but I think if they were both in aesthetic and function with the text on the side, as we talked about. I got rid of the knurling for a couple of reasons. First of all, I knew it was going to be a real pain to have raised lettering or recessed lettering with knurling. That's just going to get lost there. It would be a real pain to try and design around all that mesh. We could get this guy in here at kind of an angle like this, and now imagine we have this this flat end mill in here. This is flat across the bottom, hitting it like this, and then we turn this so that we get kind of, basically we cut kind of a chamfer into the edge of this. My lathe is not up and running. That might be an easier way to do this. Just chuck this into a lathe and turn this part and then chamfer the end. Although I'm not sure about that because the tool itself then is just going to be digging into this. It might try and pull itself in. Whereas on the milling machine, this is turning at a really slow speed. But we're basically advancing the work into the tool bit that is turning at a faster speed. Not too fast. That was the trick to getting a good surface finish here. Is I slowed this guy down pretty far. I think I was down about 700 RPMs. which
Wow,
you would
that's
go a lot
pretty
faster with a 2-4
slow.
handle, and you would for steel or aluminum or other materials. But a slow feed rate, so slowly moving the material through the milling bit or the end mill, and having a fairly slow spindle speed gives you a good finish. I don't know if that's going to translate to this kind of cut, but let me see what I have that might let us position this in the milling machine to cut that face. So I've got this. This is a dividing head. This is designed to mount something in the 3-jaw chuck here. And you can turn it with this handle. And this is a dividing disc here. You can turn it to specific angles, like if you're cutting, like if you wanted to cut hex into something, or turn a cylinder into square at the end, or any number of faces that you needed. You could even cut gears with this if you have the right gear cutters. But this guy does actually angle, so we can flip this up vertically or at any angle we want to work more like a rotary table. Now I just checked, and I don't think that we're going to get this in this 3-jaw chuck. That's just too small. Either gripping on the inside of the lid or gripping on the outside of the base or the upper part of the lid. But I have another chuck that I actually got out of a garbage pile that I was in the process of rebuilding that is nowhere near ready to use for metal, but I think we could probably make it work for plastic. Let me grab that. All right, so here's the backing plate for this truck, and I've never actually tried it, but I think the threads on this backing plate are the same as the threads on the dividing head for the 3-jaw truck. So let me see if I can get that off, and if this is even going to, we'll try just the backing plate on there before I try and reassemble this guy to use it. All right, so that does fit, so in theory this should work. So let's put this truck back together.
Oh, that's so cool. I've never seen something like that. Good looking lathe, man, or mill,
All right,
man.
truck cleaned up in place, and everything is as centered as it can be. I put 2 layers of painter's tape under here to hopefully keep these truck jaws from marring up the surface finish on the bottom part of our holder. And everything is centered within 10 thou. This face up here runs through within 10 thou, and this edge here runs through within 10 thou. I can't get any less than that. I don't think it's actually out of center. I think it's just imperfections in the print itself. So there's so many different.
Yeah, bro, I wouldn't expect anything more than that.
See what happens.
Ugh. Look at all that. It's kind of disgusting, actually.
All right. It went surprisingly well. It's hard to see it here in the...
Plastic chips are so unappealing, man.
This is a 320 grit flexible paper. Actually, this stuff has an interesting story. I bought this at Lowe's a couple years ago. It is like a plastic backed paper. This stuff never wears out, or, well, I mean, it eventually does. I think I'm only on my second sheet of it, and I thought, this stuff is great, I'm going to buy more. I think they discontinued it. I think they were like, oh crap, no one's ever going to buy sandpaper ever again. We better stop selling this. If you guys have found this plastic backed 3M paper anywhere, send me a link. I'd love to buy some more of it.
That's funny.
All right, lightly sanded that. I think that looks pretty good. Let's go.
Oh, it does look good.
All right, we're down here in my electronics bench, and if you haven't seen me use this before, this is a hot air rework station. It's meant for warming up whole chips on the surface of boards and pulling them off, but I have found that it has an even better use for cleaning up 3D prints. What I'm going to do is let this come up to temperature, and then moving around. You got to be really careful not to overheat the print, but if you get it just right, you'll return that sort of as-printed surface finish. You're remelting the plastic just at the surface and taking away all those light-colored stress marks on the plastic. And notice how quickly I'm moving. You can't stand in one place too long, but you can make more than one pass. Well, guys, it was quite the journey, but I think we
Pretty
are
neat.
there.
Pretty neat.
Hey guys, and welcome to Functional Print Friday. So last...
It's a nice little mill, man. Wow, look at the spindle speed they use. 12,000. Other mill. Dude, I'm hella tired, man. I didn't drink any caffeine today. I'm not feeling it. Damn. What were we even doing? Look, see, this thing looks good right now, but then when it gets to the top, it just looks like it just like falls apart. It becomes like tissue paper. Um, let's see what's going on. Let's just go back to this. So, okay, let me just make a new part studio. Wait, why isn't it? Okay. We just want to see, or maybe I'll build it. Maybe I'll build the gear part first. So let's do this. So spur gear. And the module is 2, I guess. But we want this pitch diameter to be. I mean, we want it to be as big as possible. Wait, the pitch though, we can't. We can make the pitch maybe like 80. We could probably make the pitch 80. Bro. I wish it would lock the. I would wish it would change the number of teeth. So let's just make this 40. Okay. And then hole, we don't need the hole. It's kind of annoying that they never put this on the they never put it on the but let's just do a transform on this thing. I just want to rotate this thing, and I wish I could select a I don't know. Whatever. We don't need to rotate it. So I just want to sketch on here so this is 84, right? Right, that sort of makes sense. Because it's times the module. It's whatever times the module. I don't think that's right. I forget what you do with the addendum. Okay, and then I just always like to do this just so that I have some points of reference. We want to do, yeah, this should be good. Then I want a driven on this. So that's 75. Let's turn that to Q. Okay. 75. And what was this? This was 80. This is 84. Oh, really? So that means that the tooth. Wait. 84 minus 75 is not. Okay, that makes sense. Okay, wait, but what was I when we go to bearing based design and then we look at this sketch, the distance from here to here is 40. Right. So what we need to do. Oh, but that is the pitch diameter. We need the what is it called? The root diameter. I think we need the root diameter to be that's nothing. Okay, so is it this? So we actually want the. So yeah, this is the pitch diameter. And 80 minus 75, this is 2.5, and then this is 4. So yeah, so this is this is 1 times the module, and the other one is what, 1.25 times the module or something like that. And we need to go a little bit bigger, but we need to keep this under 90, right? Because at 90, oops. Yeah, I kind of feel suspicious about doing that. We could make it a more complicated thing where it's like goes inwards. Oh, bro, I gotta. This has been bothering the hell out of me. Oh, I'm a gremlin. I'm a gremlin. I'm a gremlin. That means we have 6 mils. So wait, what am I actually thinking about? Because can't we just make it smaller? Like, doesn't it not matter? Talking about this. Okay, let's just try that. And we're gonna make a. So we're gonna. Oh, wait, we need to take this sketch and we need to. Oh, I see. Okay, wait, so if we were to do. Right. No, that's fine. So if we were to change this, take this face, extrude it. Let's just say by 10. And then we're going to sketch on here. And here is where we're going to make a... And this is going to be a big bearing ID. And we are going to take this and this. And we're going to extrude that by like... Yeah, whatever. 30. And then we're gonna just mirror that. So we're gonna make a mirror plane from here to here. So not that, but this plane, mid plane. Yeah, that's perfect. Or wait, actually, yeah, no, that's nah. Yeah, that's okay. So now we just want to mirror. Been driving me crazy. Okay. So yeah, so let's just make a feature mirror of this extrusion and this extrusion. And the mirror plane is gonna be this fucking guy right here. Wait, what? That seems about right. So this is a big ass thing, but the idea is, oh yeah, and then we want to just bore a freaking big ass hole through it. So we could just do this. Yeah, make that 5. Take this. Oops. remove, up to next. Right, so this is basically, oh, something happened here. But in any case, that is sort of what I had in mind. What assembly was this in? We should be able to insert it in here, right? Let's just do that. Part Studio 2. Okay, and then this. And we want it to be Revolut. And we want it to be this guy to the bottom. Yeah, like that. And this should turn, right? Okay, so this is already presenting a problem. Oh, but wait, we were gonna rotate this. This isn't gonna be like that. So we can delete what this mate. We want to actually like point it at it. The problem is there's a big ass wall there, but for the purposes of this, I guess I could just treat it like there is no wall there. Fucking how old is this LaCroix, dude? It's just water. Okay. Last thing. I feel like I'm just gonna fucking lie down until I have to go. But we got this. Let me try to find the product listing on Amazon. Wait, let's just go to Amazon. What the hell? Oh my god. Bro, what the hell, man? I literally have done this multiple times now. Fucking god, bro. I feel like it just forgets. Whatever, I'm just gonna do it over here. I don't give a fuck. Y'all can just watch this print. 10 RPM motor. I feel like even if I go to 12 volt, here we go. I think they gave me drawings. They gave me some drawings. We could probably try to speed run this. No way the shaft is 12 mils, bro. That's not even right. Oh, that's the for the notch. Okay, so let's just try to do this. Um, where should we do it? We should do it in here. Okay, so this is going to be the Create Part Studio. This is going to be the 10 RPM motor. So we're gonna try to get this done before I have to leave, which is at 5. Shapes, but I can't deny. We could put it all the rest just for one night. Okay, so here we go. Let's take this. I wonder if they gave us a CAD. GA37RG. This is probably it. Pretty good. Should we do it ourselves? I mean, this is all I need. This seems right. 50 RPM. No way the dimensions are different. Let's duplicate this. Yeah, I think this GA is so let's just I think I can log in, but ugh, bro. There's so much stuff about just using a computer that's so stupid. Please tell me I got a step file. 3D, and then we're gonna make it downloads in the 3D. Okay, now we can. That's nice though that it Wow, dude, my let me link my YouTube in my GrabCAD because evidently my GrabCAD has gotten some likes. Okay, fuck it. So we got the model. Okay, so we already have the model. We just need to adjust. Let's look at the hopper assembly. hop ass too. Okay, so basically the only thing that needs to change here is luckily we really don't have to worry about the shaft not hitting the set screws not hitting the D. The part of the problem is we're gonna have to change the hub. Dude, yeah, okay. Next stream or something, we're definitely making a script to design these set screw hubs because I've done this feature literally a bajillion times, and it's time for me to just you take a cylinder, you just define the top face of the cylinder and you define the bottom face of the cylinder, and then you well, I mean it'll figure out what the bottom is, but and then it'll just do these features because it's so absurd to like really do this again. Um, And then the other thing is the length of it. So wait, can we upload? So let's import 3D downloads. Let's just do extract all. Please don't be STL. Dude, I'm so sick of Windows actually though. This shaft has some play to it. I don't really like that actually. Yeah, you go view details, but then it still doesn't freaking tell you it just tells you it just tells you the application associated with the file type, and it doesn't tell you the file type. Because file types are scary. Because file types are very scary. Alright, so it gave me literally the fusion file, but please tell me that's not an STL. Is there a way for me to just always show this in this view? Because I'm so tired of this. Alright, it's a step file. Good. Import into this document. We could put... Okay, so it's an assembly file. Let's see. This thing probably doesn't have a revolute, right? Yeah. It's kind of a joke. But, okay, we can at least do this and this. But then what I want to do is I want to take... Wait, can we... Wait, does this open... So then... Okay. Right. So what I want to do is I want to take this whole thing. I want to split it. Entity to split with this thing. Or not face, but component one. Entity to split with, probably this. So now this is its own thing, right? Split body. How do I split body? This didn't do what I wanted. Parts, surfaces, or curves. Okay, so that's a part, but we actually want to split this. Yeah, wait. That goes all the way down in there. What is this? Okay, so this is a separate part, but it's mated or what? Can I do a transform and just drag? I can't drag it around. I kind of don't like that, but if we go back into this assembly thing, oh boy, let's just delete all this shit. I'm just gonna delete this. I'm gonna insert. What is it called? ZGA. Okay, that seems good. So now there's 3 bodies here, right? So we have the shaft, we have this. So also I'm gonna rename this, and this is going to be called the 10 RPM motor. Okay, so this thing, we need to make sure we don't mess this up. It's 15 from there. Let's look at the drawing. Yeah, that checks out. So we could put it on our wrist just for one night. Oh, I gotta get my shoes. Okay, so let's mate this. Is that the center? I don't know. So we need to do this, then we need to offset by Z by 15, and then we need to make this revolute. Sick. So now, oops. Okay, fine. So now we can make this. What is that part? Wait, can we rename these? We need to rename these. Component 1, we're gonna rename as motor base. I don't know. I don't even know what this thing is about. Okay, this is gonna be the shaft. Rename shaft. And then rename gearbox. Okay, cool. So now these things should be a little bit more sane to understand. So when I click on this, it's the gearbox. And there's that. And this is a fasten to mate. Okay, so now, and then this, I want to say, is the fixed part. So now we have, all right, so we have our motor. So that's pretty good. Now all we have to do is in hop ass, we only have a 15, it's kind of annoying how short this shaft is. I prefer the 20 mils actually because, well, whatever. Because the thing is, this is a 6. The diameter of this thing is 6, right? Also, it's got a little chamfer, but whatever. Yeah, so this is a 6 diameter, so it's a little bit wider actually than the stepper motors. That's okay, but the only problem is this. Actually, I want to check. Oh, guys, by the way, I looked at. Yeah, no one's gonna respond to this thing ever again. I looked at how many extrusion paths are in an actual print. I looked at the worm drive, and the worm drive has upwards of, I think, more than 100,000 extrusions, individual G1s where it's extruding material. So yeah, there's no freaking way that Onshape is going to be able to do what I need it to do. So I think I'm going to have to do something custom. I found a library called Seagal, and hopefully this could be fast enough. GPT told me that 100,000 unions might take a few minutes. And look, if it's an important part, I'm willing to wait actually, like, if it's a good reconstruction, maybe like 20 minutes for a good reconstruction. Yeah, unfortunately, getting a good reconstruction is actually way harder than I thought because you have to do real sweeps, and I really want someone to pick up that project and make it like a viable thing because it's just gotten so much harder. I am gonna do the Seagal thing, but dude, working with C++ on Windows is so bad. Let's see if we can actually. Let's just see if we can. Uh, they said the recommended install instructions are to the website. Yeah, cool. Download Windows. They recommend VC package. Honestly, VC package is probably not so bad, but what? Really? I could have sworn that I had this. Please tell me that there's a winget. Dude, exactly. Dude, holy shit. Bro, what the fuck? I think their recommended is that you clone it, right? Get started. Use VC package. But how do I install it, you idiots? Okay. So I'm just gonna put it here. thing is, it's so insane. Fuck, I gotta go soon. We can put it all to rest just for one night. The other thing is that this computer is like completely running out of storage. I need to get a new drive. There's 12 gigs free. Alright, well, whatever. Can you believe this? Pymol literally was like, hey, we're just gonna drop this in your fucking user home. How disrespectful is that? Oh, here we go. Okay, so now I can do VC package. Right. Right. That's cool. Why doesn't it add to the path? Let's just do this really quickly. Edit environment variables for my account. What? That is so fucking stupid. Windows is like, it's just to fucking edit your path, man. Okay. Alright. So what do I need to do? Now I need to install Seagal. Does anyone remember? I think I did this on stream. Did I do this on stream? Bro, all I did was try to build OpenCV, and it like filled my hard drive. It like filled my hard drive completely. And you know what's so stupid? On Instagram, I get this fucking guy claiming to be the CEO of OpenCV, and he's like, join our webinar for AIML. And it's like, he's wearing those stupid newsboy hats, bro. I want to fuck that guy up. Why not just make OpenCV usable? Why are you trying to market it as OpenCV University? It's just a bunch of total crap. This guy, bro. Fuck this guy, man. This is not legit. This is not legit at all. Dude, Satya Malik, bro. I'd kill that guy. Not really, but just like, it's like, I can't even use OpenCV. And they're trying to like change their business model to like sell shit. It's like, you're an open source package. What the fuck do you know about running educational things? It just so... I like some of the Gaga songs, but what the fuck does she know about cameras? You know, that kind of vibe. Bro, I love that video. Alright, so... Oh wait, let's look at our print. Hey, that's looking pretty good. Nice. But the worst thing about 3D printing is when you feel like you have to get lucky for a print to work. I mean, I just don't know what was happening last time. It was like fluffy. I wonder if I have that print. I probably junked it, but yeah, it totally bummed me out. But I can't wait 9 more minutes. I gotta run.